For example, if I take calcium ethanoate plus calcium propanoate. So in this case, if I heat it, right, then there is a possibility that this ethanoate and this propanoate combine together. This ethanoate combines with another ethanoate, and this propanoate combines with another propanoate. So there's three possible combination. So there will be three possible products. Now this individually we have seen before. If ethanoate combines with ethanoate, that will result in acetone, right? If this propanoate combines with propanoate, then from here you can see 3 carbons, C double bond O, and then you'll have this part on right hand side. The way you will write the product is this. This is coming from one of the part. This is coming from one propanoate, and this CO2 will not come again because this is going into carbonate. So on right hand side you will just have this section, ethyl part. So it will be a symmetrical ketone. So this is what you will have when propanoate combines with propanoate. You will get pentanone. Now there will be another third possibility that this acetate combines with this propanoate. So in order to write the product, you will start from acetate. So this part is coming from acetate, and from propanoate you will have again this ethyl part. So CH2, CH3. So this is butanone. You can start from this propanoate as well. If you have to combine these two, you can start writing propanoate, CH3, CH2, C double bond O. This is coming from propanoate. And for ethanoate, this CO2 won't come because this is going in carbonate. So you'll have just this methyl, right? Now these two are same. Both are butanol. If you just flip it like this, these two will have identical structure. They indeed have identical structure, but if you flip it like this, they will look same, right? The IUPAC nomenclature will be butanone or 2-butanone, same for both. So both molecules are same, right? So this is a cross reaction. If you have two kinds of calcium salt present together in the system, there can be multiple possibility of products. So you have to learn to write the products. That's it, right? So let's solve a problem based on this reaction. Suppose I have A and I heat it. Then I get benzophenone, right? So the question is, what is A? You have to think all the reactions in which you have taken only heat as the product. And as far as the reactions we have studied up till now, there are two reactions that we have used in which only heat is the reagent and nothing else. One was beta keto acid decarboxylation. If you remember, that reaction we studied in the method of preparation of ketone. And this one, the last reaction that we have studied, that also uses only heat as the product, that heats calcium salt of carboxylic acid. Now this can either be a beta keto acid or it can be a calcium salt of carboxylic acid. Now if this is a beta keto acid, then if you remember when I taught you beta keto acid, I told you that in beta keto acid carbon dioxide gas is also evolved. Here we can see that there is no carbon dioxide gas given. So this must not be a beta keto acid, this must be a calcium salt of carboxylic acid. Now there can be confusion, or there can be in exam, if you get this problem there will be more clarity. And to give more clarity, let me reframe the problem like this. Now this is very clear. You're adding calcium hydroxide, then this must be a calcium salt. Now there is no ambiguity. Now this is a calcium salt, you're heating it, you're getting benzophenone, and we have learned just a minute back how to get the product, and now you just have to traverse back. You have been given the product, now you have to find out which acid, which salt this must be. And you're getting this salt from B. The B must be an acid, and you're adding a calcium hydroxide to this, then you'll be getting a calcium salt of carboxylic acid. So once you identify the salt, you'll identify this acid. Then let me extend the problem a little bit. Okay, then this is D, right? And if I add I get E. Can we extend it more? Okay. Alright, suppose this is the problem and you have to solve this problem. Now the key is benzophenone. Benzophenone has been given to you. From this benzophenone, you will identify what A is. Now after identifying what A is, you will find out what B is, what C is, what D is, what E is, and what F is. So it's an easy problem based upon the recent reaction that we have studied in this chapter. Should not be difficult for you to identify all of them. So take a minute, think about it, work it out, and then listen any further. I'm going to tell you the answer anyway, but it will be better if you solve it on your own and then you listen to the answers and then see what you have been learning. Benzophenone. The first thing is you must know what benzophenone is. And I hope you all know what benzophenone is. Benzophenone looks like this. This is benzophenone. You are heating a calcium salt and you're getting benzophenone. So what that calcium salt is, we have learned that this part comes from one of the salt and this part comes from another salt. And the C double bond O or CO2 part of this part is going into carbonate. So the salt must be, or A must be, this. Calcium benzoate. This part is coming from benzoic acid. So the salt would be calcium benzoate. And B must be benzoic acid because on reaction with calcium hydroxide, it's giving calcium benzoate. So B is benzoic acid. Right? You're getting B from D. And you're doing hydrolysis. D on D, if you carry out hydrolysis on D, you'll get B, and along with B, you're getting a gas C. So, which reaction is this? As such, I haven't taught you directly this reaction in this chapter because this reaction comes in the chapter of carboxylic acid. And I have told you that this cyanide, when we hydrolyze this, because this, when you have C double bond N and you have a H here, we studied this compound in Stephen's reaction. Stephen's reaction I have taught you in the method of preparation of aldehyde, and we hydrolyze this in Stephen's reaction, and the mechanism also I taught you. This turns out to be a aldehyde. And when we were studying further ketones in one of the conversion problem, I told you that in cyanide, when we hydrolyze cyanide, when we have C triple bond N, this turns out to be a carboxylic acid. When you have a C double bond N on hydrolysis, it turns out to be a aldehyde. Now we have seen this before. In the previous lecture, I have told you. Formally, I haven't taught you, but in one of the problem, I have taught you this. I have told you this, that the cyanide on hydrolysis gives carboxylic acid. And Stephen's reaction also I have taught you that this nitrogen comes out as ammonia gas. We have seen this. So in this case also, this nitrogen will come out as ammonia gas. So based upon that, you must be able to understand that this acid comes out as a hydrolysis product when the reactant is cyanide, and the gas which comes along is ammonia. So C must be ammonia gas and D must be a cyanide, right? So C is ammonia gas, and D, the structure of D you would know by the structure of B. B is having this ring, so the ring would be there in D as well. So the phenyl ring would be there. Outside phenyl ring you have one carbon. That one carbon should be coming from cyanide. So D must be benzonitrile or cyanobenzene, right? So this is D. Now this is the Grignard reagent reaction on a cyanide. When I taught you this reaction, I told you that this is an important reaction, and somewhere in the conversion problem that we'll be solving ahead, this reaction will appear, and that turns out to be true. Somewhere in the conversion problem this reaction is appearing. So this reaction we studied when we studied the method of preparation of ketone, right? And we know what this reaction is, we have dealt in detail. So it shouldn't be a problem for you to identify E if you have studied this reaction. If you haven't studied this reaction, go 2-3 videos back. Search for this reaction in the method of preparation of ketone and you will find out. And then come back and then solve it. And I'm sure you would be able to identify E, and this E is acetophenone. Last reaction, which is giving you E from F, seems to be a Walker reaction. If you add water here. Now this Walker process, I told you that this is an important industrial chemistry reaction, and we studied this reaction. We know what happens in this reaction, and shouldn't be very difficult for you to identify that F is styrene. Now the whole thing will be very, very interesting and engaging if you are remembering the reaction. Now I taught you Walker process. If you didn't learn the Walker process, if you don't know what happens in Walker process, I directly wrote F as a styrene. Now your head may reel if you don't know what Walker process is. You will not be quickly able to write what F is. But I suggest you, when you are studying the reactions and we are moving ahead, you have to remember all the reaction. When you remember all the reaction, this kind of conversion problem concretize those reactions into your brain. So those things gets engraved into your brain after solving these kind of conversion problem. So as you are moving ahead, make sure that you know all the reaction that have been taught before. Then only you'll be able to enjoy the whole process. Otherwise, it's going to be a headache. So from now we have completed all the method of preparation of aldehyde and ketone. So it's done. So from now we will be studying reactions of aldehydes and ketones.